Resistivity. Resistivity is a value for a material, whereas resistance is a value for a component. And for both, it is their ability to resist the flow of current. Resistivity for any material would be the same. For instance, copper, no matter where it comes from, would have the same resistivity, whereas you could have two components of varying sizes, both that have different resistance. If you know the resistivity of a material, you can work out the resistance of a component by calculating the resistivity by the length of the component and dividing it by its cross-sectional area. Here we have that explained again, but we can rearrange this. So if we know the resistance, the length and the area, we can also work out the resistivity. Calculating a value for R. If we're given the resistivity, the length and the cross-sectional area, we can work out R. R is equal to rho L divided by A. If we substitute the values in, we find that the resistance of this component would be 6.72 times 10 to the minus 8 ohms. Let's now flip that around. Let's imagine we have a component where we know its resistance, of which we will show that on the screen in just a second. We know the dimensions of the component, but we want to know what material it's made from. We could work out the resistivity of the material and then match it up with the material that it would be made from. So we would have to use the equation rho is equal to Ra divided by L. We now have the resistance value given to us, which is 40 times 10 to the minus 6 ohms. If we substitute all those values in, we find that rho is 1.0 times 10 to the minus 7 ohms meters. Can you find out what material this block is made from? Now let's talk about superconductors. What's a superconductor? A superconductor is a wire or device that has zero resistance, and that has zero resistance below a critical temperature. So it doesn't always have zero resistance. We have there a picture of a graph representing the resistance in relationship to temperature. We see that above the critical temperature the resistance is quite high, and below the critical temperature the resistance is zero. When current flows, there is no PD across the conductor because there is no resistance. This means you get no heating effect because there is no power lost through the wire or the device that is the superconductor. Now let's recap. Resistance is equal to resistivity times by length divided by cross-sectional area. This is represented by R equals rho L divided by A. We can rearrange this to get resistivity on its own. Resistivity, rho, is equal to Ra divided by L. A superconductor has zero resistance below a critical temperature, and that critical temperature is individual to the material. Therefore, the critical temperature is different for different materials. Feel free to look through this video again and make notes, pausing at your own pace.